Hi folks, we're going to take a look at number 8 from page 575 here, and they're asking us to find the equation of the tangent to this curve that is parallel to the given line. Okay, so since we're looking for the equation of a tangent, which is a line, we need a slope and we need a point. Okay, so the slope is the easier thing to get because I know that whatever this tangent is, it needs to be parallel to the given line. So that means these two lines are going to have to share the same slope. So here I'm going to solve for y. So we've got 6y equals 3x minus 1, and divide 6 to both sides. So 3 over 6 is 1/2 x minus 1 over 6. Okay, but that's really the only thing I'm interested in. So I know that the slope of my line is going to be equal to 1/2. So next goal is to determine a point on this line. Well, what I'm going to do is I'm going to determine the point that the tangent and the curve share. Okay, so that means I need to determine an x value for which the derivative of this function, which of course is what gives me the slopes of the tangents, is equal to 1/2. Okay, so next step is to find the derivative of the function. Derivative of ln x is just 1 over x, and derivative of 1 is just equal to 0. So I'm done here, and I need to figure out when this derivative is equal to 1/2. Whoops, there we go. 1 over x. So should be easy to see that x must be equal to 2, but even if you solve this out, so cross multiply, bring the x to that side, 2 to the other side, we get x equals 2. Okay, so this is the x value of the point on the curve, okay, which has the tangent we're looking for, so which the tangent also possesses. So that means we need to find the y value. So since this point is both on the tangent and the curve, I can use the curve to find the y value. So the y value here is just going to be ln 2 minus 1. Okay, so what we have is we have the three components we need. We have the slope, we have the x value of the point, and we have the y value of the point. Okay, so now I've got a couple of choices to find the equation of this line. Well, actually, for this video, I'll do it in both ways. So I'll use this new method, which I suggested you use, which is the point slope form. Okay, that's the one that's most straightforward. So slope form says that the equation is given by y minus the y value of your point, so ln 2 minus 1, equals your slope, 1/2, times x minus the given x value of your point. Okay, and there you go. There's one form of the equation. Okay, no solving for b. The other option is the slope-intercept form. Okay, y equals mx plus b, and you solve for that b value, which is your intercept. So here, let's stick in the y value, ln 2 minus 1 equals m 1/2 times x, which is 2, plus b, and now we can solve for b. And this is actually a pretty easy one in this case here. So we've got ln 2 minus 1 equals 1 plus b, and we'll subtract the 1 to the other side, so ln 2 minus 2. So our equation is y equals 1/2 x plus ln 2 minus 2. Okay, so you notice here significantly more steps to write out, but we should show that these two things are equivalent. So let me solve for y here. So we've got y equals, well, this becomes 1/2 x minus 1. Okay, and here I'm going to add ln 2 plus 1 to the other side, so plus ln 2 plus 1, and here we've got minus 1, my mistake. So y is equal to 1/2 x plus ln 2, negative 1 minus 1 is minus 2. And we see that they're the exact same thing. Okay, but in terms of actually writing out the equation, this one's quicker. But if you still want to use slope-intercept form, you're more than welcome.